Hello ROS developers and welcome to a new live class 117 where we are going to be talking about ROS2 services with C++. So let's start. Alright, so hello there ROS developers and welcome to this live class number 117 where, as I have just said, we are going to be talking about ROS2 services, in this case in C++. We already did them some weeks ago. We already covered ROS2 services with Python in that case, so today we are going to do them using C++. Also, as you can see, we are in a new environment, a super cool environment. So we have upgraded our place for the live classes. I hope you like it a lot. As you can see, we have some robots here and there. For instance, we can see there a BB-8 robot, and I challenge you to find them all. So we have some of them, some robots hidden here in the environment. So yeah, I hope you like it. And this is not the only new thing we bring today for today's live class. There's another feature that I'm going to introduce to you today, but we are going to see it in a moment. So first of all, I want to make sure that everything is fine, so that video is fine, you can see me properly, you can hear me properly. Let me know in the chat if everything is fine, so that we can keep going. So let me quickly have a look at the chat to see what feedback do I get. Der Capute says that he's not going to be able to follow this lesson. Don't worry, you can retake it later. Everything is all good, says Tom Rowland there. All right, fine for me, says Thomas also. Okay, then let's go for it. So let me know, are you new in live classes? Is this your first live class, second one, third one, or you are already a war veteran? All fine, all good. So basically this is going to work more or less similar to all the live classes. So we are going to still be sharing a project with you guys so that we all together can practice here. This is my first live class, I can see. I'm new. Ajinkia, Stefano, first time, says also Tom Rowland. Fourth, says Thomas. All right. So let's keep it simple and let's go step by step so that you don't get lost. Then for the new ones, let me explain you what this is going to be about. So this is going to be an hour, a live class, where we are going to be teaching, in this case, ROS2. So we have a live class every week, every Tuesday at the same hour, and we are covering different topics, ROS2, ROS1, robotics also, many things related to AI, for instance. So each week we are going to be covering a different topic. This week's topic is ROS2 and specifically ROS2 services using C++. So in order to practice, I'm not going to be talking to you and you're going to be listening to me and taking notes. No, that's not the way we want to work. So we want to learn by practicing. And in order to practice, you need to have something to practice with. And this is going to be the ROSject. So I have created a ROSject where I have placed there some ROS2 packages, a simulation, and some instructions so that we can learn while we practice. And I'm going to share this ROSject, which contains all of this, with you right now, so that you are going to have the same environment that I'm going to be working with. All right? So that's the idea. The idea is that while I am explaining different things and while I am creating packages, creating programs, etc., you're going to be able to listen to me, to watch me, but I challenge you to do the same that I'm going to be doing. So not just stay there listening or watching to what I am doing, but to practice with me. All right, so that's the idea. Then, as I've said, how we are going to achieve this? We are going to do it with ROSject, with our ROSject, which is basically a self-contained ROS project. Okay, so let me stop talking right now, and I'm going to switch to my computer screen. So Let me do it right now. All right, so here I am in the construct web page. This is basically where we are going to be doing all of this. Then first thing you need to do is to create an account in case you don't have it. It's completely free. It's going to take you just some seconds. So just sign up, create an account in case you don't have it, and then log in. So I'm going to log in right now to my account. Here it's my account. Then here in my ROS-based section, basically is where I have all the ROS-based. So the construct application main page can be divided basically into different sections, as you can see. First one is the Robotic Night Academy, where basically you are going to find all the courses. So for instance, you can click here in the courses section, and you are going to find all the courses that we provide, courses related to robotics, courses related to robotics theory. As you can see here, for instance, we have robot dynamics and control, kinematics, Kalman filters, etc. We have also courses for ROS, basic ROS in this case, ROS2, also more advanced ROS topics like navigation, manipulation, perception, etc., etc. So basically here is where you are going to find all the courses. Okay, then we have a section here which is live classes. Then if you come here to the live classes section, you are going to see all the live classes. We have a section here. Oh, I'm hearing myself. Let me mute me. All right. Then here you can see current live class. Yeah. So here this is actually the live class that I am doing right now, live. Okay. Then you can click here in this button, fork and open the class ROS-based. Then by clicking in this button, you are going to basically get the ROS-based for today's live class, and it's going to be opened automatically for you. Okay, so please do it. Click here in the fork and open the class ROS-based, and this is going to basically open the today's ROS-based automatically. Okay, I'm going to come here because I have created it and I have it here. So let me run it also myself here. So basically, once you open the ROS-based, you are going to get something like this. So by default, automatically, it's going to open a Jupyter Notebook window, as you can see here. I'm going to wait some seconds or minutes until everything gets loaded. So since we are many people here right now opening it, it might take a few moments to load. There we have it. So here my ROS-based has been loaded, and by default it has opened here my Jupyter Notebook. So I'm going to click, in this case, in the default notebook, and this is going to open here the Jupyter Notebook for today's live class. You can see here it's the ROS Developers Live Class number 117, ROS2 Services in C++. Then so far so good. So for the ones that you have already been doing live classes, more or less this is the same as always, even though you can now access the live class ROS-based easily directly from our page, which is cool. As I have just explained it, you can do that. Let me go back here. So one of the new things that we have introduced now is that you, as I have just said, you can access the live class directly here from the page. Yes? So by clicking here in the fork and open the class ROS-based, you can automatically get the ROS-based. So I don't need to share with you in the chat, copy paste the link as I was doing until now, the ROS-based. So you can get it directly from the page. All right? Then a second thing that I want to introduce today is this button. So maybe you have already seen it. So we have added this button here, and by clicking in this button here, you are going to get access directly to the live class. Okay, so you can visualize it directly here. You can open it in a new tab in case you want to get it bigger or you want to access to the chat. So you have this button here, which basically is going to allow you to be seeing the live class and listening to the live class in the same page where you are going to be working in the ROS-based. So until now, basically you had to have the ROSject page open it in one place, and then the YouTube live open it in another place, which is sometimes it was a little bit cumbersome. So now we have put everything together into the same place. So in the same ROSject where we are going to be working, you can have access to the live class live image. So at this moment, you can't access directly from here to the chat. That's not possible, but it's going to be in the future. So we are still working in this implementation, in combining the live class with the ROSject. So for now, we have only the image, but in the close future, we are going to add also the chat so that we have absolutely everything in one single place. All right, makes sense? So let me have a quick look at the chat to see how are you doing. So at this point, basically, all of you should have the ROSject opened with the notebook for today's live class also opened and prepared here, which is basically the instructions that we are going to be following. So let me know if we are all together in the same point. If you got lost at some step, let me check the chat here real quick. I can see Ricardo says that you are hearing me double. I have muted the live here. Maybe it was because of this, because the live stream here, it was not muted. So at this point, all right, now solved, no worries. Okay, great. So yeah, probably it was because of that, because I had the live streaming with sound. So now that it's muted, everything should work fine. Let me check a little bit your comments. Richard Williamson says, I've taken a few of your classes. Hopefully you will be using Foxy. Yes, so Richard, we are going to be using Foxy for today's live class. If you come here, you are going to see that the ROS distribution that we are using is Foxy. So we are now up to date. Thanks for explaining. Awesome, no worries. Can you share a link again of ROSject? So I can see Amna is asking for the share link of the ROSject, also Vignesh. So today's live class, it's going to be a little bit different. So I'm not going to share the ROSject here in the chat, but you can get the ROSject directly in our platform. So let me explain it one more time. So in the construct application where we have been working always, I have just explained it that here in the Robotic Night Academy section, we have a button which takes us to the live classes page. Then if we click here in the live classes page, I'm going to mute myself here again. There we go. So as you can see here, you can see the live streaming, the live class that I'm currently doing. So this is the current live streaming, and here at the right side you have this button in purple, in light blue color, which says fork and open the class ROSject. Then by clicking in this button, you are going to automatically fork and open the ROSject for today's live class. So it's not required anymore that I copy and paste the ROSject in the YouTube chat. Okay, so you can do it directly here from the page without the process of copying and pasting, which was a little bit cumbersome. So now it's much more easier. So just by coming here to the Robotic Night Academy section live classes, you are going to be able to get directly the ROSject by clicking in this button, fork and open the class ROSject. Make sense? So Marco says, I used the fork and run by my Jupyter notebook. Doesn't look like yours. All right. So the Jupyter notebook should be like this one. It's not like this one. ROS Developers Live Class number 117. No? Let me know here in the chat if you are seeing the same Jupyter notebook that I have here, it should be titled like this: ROS Developers Live Class number 117. Are you seeing the same Jupyter notebook or not? Let me know, please. It does for me, says Ricardo. Maybe you mean that it opened automatically. Oh yeah, in my case, for some reason the notebook didn't open automatically here. So sometimes it opens automatically here in this page, the Jupyter notebook. In my case it didn't, so in case that you get the same as I am getting here, you can just click here in the default EPI notebook here in this file, and this is going to open automatically the project here in a new tab, like it's my case. Let me see this. Mine's the same. Tom Rowland says that his project is the same. Okay, this is important because we should all have the same project. If not, this doesn't make sense. So I'm going to suppose that all of us have the same project. Let me see if I can get one more confirmation at least, so that I am sure that we are all having the same project. Also, Amna Mazen says got it, so he already has the project. Okay, so meanwhile, let me keep advancing a little bit with the setup of the live class. So, as I have explained at the beginning, here is where we are going to have the instructions for today's live class. This is what I'm going to be basically following. Then here we have some requirements. So in order to be able to properly follow this live class, you should have a background, at least some basic knowledge of Linux systems, a little bit of C++ basics, since we are going to be programming today using C++, and also since this live class is going to be related to ROS2 in C++, so also I have linked you here a course that we have about ROS2 basics in C++. You have all the links here. Remember, I am going to explain it one more time. Here in the Robotics Academy section, you can come to the courses page, and here you're going to find all the courses. So here in the notebook, I have just linked the ones which are more related for today's live class. So you can click here and check them. All right. Then, as for the setup, we are going to start by launching the simulation. Then for this, the first thing we are going to do is to open a new web shell, a new shell. Then in order to open a shell, we have to click in the web shell icon, which is here, the first one, starting from the left. Then if I click here, this is going to automatically, as you can see, open a new shell. This is basically a regular Linux shell, like the ones you have in your local systems. So nothing extraordinary here. And remember, in order to open a web shell, you have to click in the web shell icon, which is the first one here in the bottom menu, starting from the left. Then here we are going to be able to start executing different commands. In this case, the first command that we are going to execute is this source. So we are going to source the ROS version that we are going to be working with today. So you can type it if you want. I suggest you to just copy it directly from the notebook. You can copy it directly from here, or with the shortcut, with a shortcut like Ctrl+C, whatever your system is. I suggest you to copy it and paste it because this is going to make things faster. So in my case, I'm going to copy it directly here from the notebook, and I'm going to paste it here in my shell. Then I'm going to execute it, and now basically what I have done is to source the ROS Foxy distribution. So now I'm going to be able to execute ROS2 commands. The next thing I'm going to do is to source my simulation workspace. Let me copy and paste it here, execute it, and now I'm going to explain what this is doing. So first I have sourced the ROS2 distribution I want to work with, and next I have sourced, as you can see here, this simulation workspace. Then what is this simulation workspace? So in this project I have shared with you that you have opened it there in your computers. You have different workspaces. You can check them, for instance, by doing an ls directly here, but you can also have a look at them in a graphical way using the IDE. Then how can you open the IDE? Very easy, by clicking in the second icon here in the bottom menu, which says Code Editor. If you click here, this is going to open the integrated development environment, which is going to allow you to interact here with all the workspaces that we have. In this case, we are going to be only working with the ROS2 workspace. Here is where we are going to create the packages for today and the programs for today's live class. But you can have a look also here at this workspace, which is called Simulation Workspace. Then inside this, by the way, here you can also minimize. I'm going to minimize it, since I am the one giving the live class. I don't need to see what I am doing. It would be a little bit kind of inception thing. So I'm going to minimize here this so that I have more space. Then here in the simulation workspace, I have placed some packages related to the Turtlebot 3 simulation for ROS2 Foxy. I have already placed all these packages here. Then I am basically sourcing this workspace because right now, next thing I'm going to do is to start my simulation. Okay, now it has reconnected. Okay, strange thing. All right, so yeah, next thing is to run this script. Then in order to run this script, we are going to do it. We are going to go first to the simulation workspace inside the SRC folder, and here you're going to see that we have the T3_Foxy. We are going to go inside using normal cd commands from Linux. Then inside here, if we list the files, we are going to see different scripts, sh files, as you can see here, and we are going to execute, in this case, the startsim.sh, as it is stated here in the notebook instructions. So let me run this script, and this is going to automatically start the gazebo simulation. If you can have a look here in the IDE to this file, you can open it. Let me put this bigger, 1 second. So in the IDE, of course, you can do whatever you do in any development environment. So you can open files, visualize its code, you can create new files, create new folders, etc., etc., etc. So in this case, if we open the startsim.sh file, which is the one that we have just executed, we're going to see what actually it is doing here. So we are sourcing some gazebo related files. We are setting also some environment variables related to gazebo, etc. And at the end, we are running this command, which is the ROS2 launch, which is the one that actually it's starting all the simulation. All right. Then here we have executed our script, which has started the simulation. So now the simulation is running, but we cannot see it yet. So in order to visualize the simulation, which is running in gazebo, by the way, we need to click in this icon, this cube icon that we have here. It's the fourth one, starting from the left. Then if I click in this icon, this is going to open a gazebo window. And in this gazebo window is where I'm going to be able to visualize my simulation. As you can see, here it's a simple simulation with an empty world, and we have a Turtlebot 3 here in the center of the simulation. All right. Excellent. So until this point, we have done the setup. Today I have taken a little bit more of time with the setup because of the all new features that we have introduced. I wanted to explain them all and make them very clear to you so that you know how to proceed for next live classes. Then, yeah, so we have, first of all, forked the live class. You have, in this case, forked and opened the live class project. you have opened the notebook with the instructions for today's live class, and finally you have started the simulation, which you can visualize here in Gazebo. All right, so are we all in the same page? Have all of you reached this point? Let me know in the comments, please. I can see all the messages now. Same for me. Mine is the same. Great. I opened wrong project. Now it worked. Okay. Marco opened the wrong project. Yes, says Albert Lopez. Yep. Thomas. Okay. So looks like all of us, we are now in the same page. So we are ready. Are we ready to start with the live class? Yes. Let's start with it. All right. Then let's start with the actual live class. Okay, so once we are all set up, by the way, I'm going to minimize this shell here, because in this shell is where I have the simulation running, so I don't want to close it by accident or anything, so I'm just going to minimize it, and I'm going to open here a new web shell by coming again to the web shell icon and clicking on the plus button here to open a new web shell. So there we go. Okay, let me close actually let me minimize this. I don't need it. All right, so here I have my web shell, my simulation, the IDE, and the Jupyter Notebook. So let's start with the current live class. Then today we are going to be talking about services. So first of all, what is a service? Well, a service in ROS2, it's very similar to what a service is in ROS1. So basically, services are another method of communication for nodes. Then services are based on a call and response model versus, or in the other hand, topics, for instance, are based on a publisher-subscriber model. If you already know about ROS topics, so you are probably familiar with the publisher-subscriber model of topics. Then in this case, services work on a model based on call and response. Then what does this mean? Well, while topics allow nodes to subscribe to the data streams and get continual updates, services only provide data when they are specifically called by a client. So when nodes communicate using services, the node that sends a request for data is called the client node, and the one that responds to the request is the service node. So we can see here a GIF, which I have taken from the official documentation. So basically we have here two different ROS nodes. We have node 1, let's say here, and node 2 here. Then in node 2, in this case, we have the service server, which is basically the program. The service server is the node that provides the functionality of that service. Then in node 1, in this case, we have the service client. Then service client is the one which is going to call to the service server for that specific application. Then the service server is going to do whatever it has to do, and when it finishes, it's going to return a response to the client. So this is basically the general idea of how a service works. So a service basically is divided in two parts, we can say, which is the service server and the service client. Then the service server is the one which actually has the functionality, which provides the functionality. But in order to get this service server to do something, we need to call it. And we call it using a service client. And in order to call it, we send a request message, as we can see here. So from the client, we are going to send a request message to the server. Then the server is going to do whatever it needs to do, and it's going to return a response to the service client. Yeah? So this is the theory, this is the theoretical approach to a service. However, as I have said at the beginning of this live class, we don't like too much the theoretical part of things, so we prefer practice. We want to see how this is applied to the real world. So this is what we are going to do right now, and this is going to help us better understand all this diagram that we have here. Then let's go for it. So first of all, of course, if we want to write a service from scratch, we need to have a service server, right? If we don't have a server, the client doesn't make any sense, because the client needs to call a service server. So if we don't have a server, we don't have a client. So the first thing to do is to write the server, the service server code. So that's what we're going to do right now. Then let's just start here again by sourcing the ROS2 distribution that we want to be working with, which is Foxy in this case. So I'm going to copy and paste this command here to my shell so that I can now start typing and executing ROS2 commands. Next thing. So the very next thing is to create a package. So I need to create a ROS2 package so that I can place my programs there. So let's go to the ROS2 workspace. We are going to be creating our package in the ROS2 workspace. You can see it here from the IDE. And as you might already know, if you are not new to ROS, and if you are, I'm telling it to you right now. Every time you create a ROS package, you have to place it inside the SRC folder of your workspace. All right. So I'm going to go there. Not Cooking Workspace, sorry, ROS2 Workspace, SRC. I'm going to home to this folder, very important that you are in this folder, ROS2 home, user, ROS2 Workspace, in this case, SRC. Then once I am inside this folder, I'm going to execute this command, which is the one that is going to create the ROS2 package. So ROS2 package create. Here we have the name of our package, which in this case is my service server. Here we specify the type of package that we are going to create. In this case, it's based on Ament CMake, which basically means that this is going to be a C++ package. If we were going to build a Python package, this would be Ament Python instead of Ament CMake. Okay, in this case it's Ament CMake, which means that we are going to create a C++ package. And then finally, at the end of the command, we are specifying some dependencies here, which are RCL CPP, std srv, and geometry messages. Okay, basically RCL CPP is the module that is going to allow us to create programs for ROS2 with C++. And these two other dependencies, we are going to see it right now in the code. Okay, then I'm going to execute this command here, and now if I open the SRC folder, I'm going to see that a new package has appeared here, which is named My Service Server. This is the package that I have just created here with this command. All right. Okay, so now I have my ROS2 package. Next thing is to create my code, my program, my ROS2 program for my service. Then, in this case, we are going to name our program, our script, like this, my_service.cpp. Then you can create it here from the web shell, but in this case I prefer to do it directly from the IDE. So I'm going to create it directly here from the IDE. And also remember that whenever you create a script, you need to place it also in the source folder, in the SRC folder. So in this case, I'm going to come here to the SRC folder. I'm going to right click here with the mouse. I'm going to right click, and this is going to open the menu. And then I'm going to click on the new file. I'm going to create a new file, and I'm going to name it my_service.cpp. There we go. And as you can see, it has automatically opened the script here in the IDE, and right now it's empty, the script. I have just created it, so it's empty. So the next step is to put some code into it, and here in the notebook you are going to find this code. Okay, so here we have the code that we are going to have to put into our script. So what I'm going to do right now is to copy the code here, select all the code and copy it from the notebook, and I'm going to paste it directly here to my script in the IDE. Paste, okay. Please use the browser's paste command or shortcut. Okay, so it's not allowing me to copy and paste it like this, so I'm going to do it with the shortcut. Control C here, Control C and Control V. There we go. Okay. Let me get a drink here from my cup. All right. So we have done already quite a lot. We have created our ROS2 package and we have created our script. So let's have a look at this script at this point. Let's have a look at what is going on here. So basically, as you can see, this code is in C++, of course. And first of all, we have the include. So we are including some modules that we are going to be using for our program. First module is RCL-CPP. Second one, I am including here this trigger message, which is a service message. Okay? And I'm also adding, in this case, the twist message. All right? Then right here, I am creating a publisher. Okay? Well, actually, I'm not creating it right yet, but I am declaring this variable, the publisher, which is going to be a publisher in the future. But I am declaring it here as a global variable. All right? Next thing is that I am also creating a message, a twist message in this twist variable. And finally, I am also declaring here a loop rate variable, which is going to control the frequency of my loops in my program. All right? Then, next thing is that I am here declaring the move function. What is this move function? This move function is the callback of my service. All right? So whenever I call my service, yeah, remember always this diagram, this workflow that we have here. Whenever I call my service server, a function, a callback function is going to be triggered. Whenever you call a service server, here some kind of callback function is going to be triggered. In this case, whenever we call our service, the service we are creating, this move function is going to be triggered, is going to be called. All right? And as you can see here, we have two different type of messages for this function. One is the request and another one is the response. So in the request variable here, we have the request part of the message. Remember, the request is the message we send from the client to the service server. And down here we have the response part of the message, which is the part that we return once we have finished it from the service server to the client. All right? Then inside this function, which is all this, basically, this is the core of our service. This is the functionality that our service is going to be doing. In this case, it's very simple. So as you can see, I am providing here a value for the linear X component of my twist message. Remember that twist messages are used in ROS and also in ROS2 in order to send velocity commands to robots, to mobile bases, so that we can control them and move them. So in this case, I am adding here a value to the twist message that I have declared here. So here I am assigning to it a message, a value, which in this case is a 0.3. So I want my robot to move in the x-axis, in the linear x-axis, with a linear velocity of 0.3 meters per second. So next thing, I have a for loop here, a super simple for loop. So for 5 seconds, basically, so as you can see here, I am initiating my variable e to 1, and while or for this condition, so meanwhile my variable a is lower than 5 and RCLCPP and my node is okay, is running, I'm going to publish this twist message. Alright? So, basically well, actually it's not for 5 seconds, but it's for 4. It would be for 5 seconds if I change this 5 to a 6. If I have a 5 here, it's going to be 4 seconds. Yes, because in the first iteration, the a variable is going to be 1, in the second one is going to be 2, in the third one is going to be 3, in the fourth one is going to be 4, and in the fifth one is going to be 5. So it's not going to enter already because this condition is not meant. Okay, anyways, these are programming concepts. I'm not going to get into this right now because it's not the purpose of this live class, which is services. Alright, so we have a very simple for loop here where we are going to be publishing twist messages to our robot for 4 seconds. Then, after these 4 seconds, we are going to send a velocity of 0, so we are going to stop the robot one more time. And then we are going to return the response to our client. In this case, the response has 2 components. A boolean, which is named success, and a string, which is named message. And why these 2 components and not others? We are going to see it in a moment. Don't worry, okay? Then finally here we are just putting some logging messages, okay? Then finally, once we have finished here the callback function for our service, here we have the main function of our program, where basically we are initiating our node. As you can see here, we are initiating a ROS2 node. We are declaring here, very important, our service. So we have some things here. So as you can see, we are declaring a service. Yes? And we are using the create service function here. Then, very important, we are setting here the name of our service. So our service is going to be named my service. And here at the end, we are declaring the callback function for our service, which is move. Is the function that we have defined right above, right here, okay? Then here in between we can see this std service trigger, here, also here. Here what we are doing is we are defining the message that we are going to be using for our service, okay? We are going to learn a little bit more later on this when we execute this service, okay? For now, just keep in mind this, that whenever we create our service here, we need to specify first the type of service message that we are going to be using. In this case, it's trigger, which by the way is the one that we have imported here at the beginning of the program, if you remember. We also have to specify the name of our service, which in this case is my service, and you need to specify the name of the callback function, so that when a client sends a request to this service, this callback function is going to be activated. Yes, and this callback function is defined here. Then finally here we are also creating our publisher. So we create the publisher, which is going to be using twist messages as we have seen before, and this is going to publish into the topic command vel. All right. Okay, so we have done a quick review here of the code. So does it make sense, more or less? Let me have a quick look at the chat. Oh, super nice comment from Alejo here. Thank you very much, Alejo. Really, thank you for those nice words. Could you move this into a node? Was trying to do this today, but struggling. I mean the client side. Yeah, sure. Rinke, you can put the client in a node. maybe we could do this for a different live class. Today we are focusing more on the server side, which is the program that we are creating now. And as a client, we are going to do it directly from the command line. We are not going to create a program for being a client, but it can be, the client can be in a node also, of course. You said when you build a new package, you need amend CMake for C++ package and amend Python for Python package. Can you create a package with C++ and Python? As far as I know, Thomas, no. So maybe there are some hacky ways of doing that, but in a standard way of working, that's not possible, as far as I know, Thomas. So you can create a package for C++, which is going to generate the CMake list files and everything, and you can create using amend Python a package for Python, which is going to not work with CMake list, but is going to work with a setup.py file. So those are different. The packages are going to be different when created for C++ and for Python. So by default, this is not possible. Maybe there are some ways of tricking the system into that, but I don't know anything about those ways. So my answer would be no. Okay, thanks. Okay, so let's keep going. So we have created our C++ script here with the code for our specific service server. Then next thing, what is to compile, right? Then in this case, in order to compile, we need to add some lines to the CMake list.txt file. Yes, this is the file where we are going to put all the instructions in order to build our program. For instance, this CMake lists.txt package is super important for C++ because here is where we are going to put all the instructions in order to build our package. But for Python packages, for instance, we don't have this file. Yes, that's the differences, for instance, related to the questions you were making between Python and C++ packages. Okay? Then, give me just 10 seconds here. There we go. All right. So as I was saying, here we are going to need to add some instructions in order to build our program. Then these instructions, you can find them also here, right below the script code. Okay. So I'm going to, again, verily copy them here and paste them. I'm going to paste them here at the bottom of the CMake list.txt file. So here, at the end of the CMake list file, you are going to see this amend package. So right above here, I'm going to paste this section here. Okay? So basically here, as you can see, what I am doing is to generate an executable from my C++ script. Yes? So from my script, which is this one, my service.cpp, I'm going to generate this executable, which is named my service server. Then I am just setting some dependencies for my executable, which are these ones, rclcpp, standard services and geometry messages. And finally, I am installing all these files into my install folder. Here we have it. Okay, so I'm going to generate my executable with its dependencies. I am going to install, I'm going to place all these executables, well, this executable in this case, into the install folder of my workspace, which is actually here. All right, so that I can run it without problems. Then, once this is done, once I have added these lines to my CMake list file, I am ready to compile. And in ROS2, we compile using the colcon build command. Also very important, in order to compile, we need to do it always from the root of the workspace. If you remember, I have said before that for creating packages, we need to be in the src folder. But for compiling, we need to always be in the root. So that's why I have gone one folder down. You need to be placed here in the root of the workspace. Then here we can run the colcon build command without problems. Now this is compiling. And there we go, it has finished compiling. Okay, here you are going to get a warning, as you can see, which says, hey, the request parameter is not being used. This warning refers that this request parameter, we are not using it inside the function, which is true. Actually, we are only using the response parameter. But this has a reason. We are not using this for a reason, which we are going to see in a moment. Okay, so don't worry about this warning. In any case, this has compiled successfully. So the final thing after compiling my service is to source my workspace so that I have the latest executables generated. Here I can run them without any problem. Okay, so there we go. We have created our package, we have created our script, and we have compiled and generated an executable for our program. Then the final thing to do here is to run it. So we can now that we have generated the executable, we can run this executable with the following command. So ROS2 run, the name of the package and the name of the executable, which in this case are the same. If I'm not wrong, my service server. Yeah, here we have it. ROS2 run my service server. I run it. And here I can see the message service ready. So now my service is running. All right. But okay, so we have finished the first section. Let's move to the second section real quick. Now, okay, yeah, so I have executed my program. I have executed my service, but how do I know that my service is really running there? Very easily. So for this, we can use the ROS2 Service List command. This command is going to is going to show me all the services that are currently running in the simulation. So if I execute this command, I have opened a new shell, So in this first shell is where I have running my service server, okay? Then I want to keep executing other commands, so basically I have clicked here in the plus button, which has opened a new shell for me, okay? So here now I can switch from first shell to the second one, okay? So now here I'm going to run the ROS2 service list command and it's going to give me an error. Why? Can somebody tell me why I'm getting this error? It is saying ROS2 command not found. Can somebody in the chat tell me why this is happening? Why I'm getting this error? Need sourcing. Very well, Amna. Very well. I need to source the ROS version I want to use. Otherwise, as you can see, I am not able to execute ROS2 commands. So let me do this. Source opt ROS foxy setup.bash. Then now I can run the command. So as you can see, we have many services here. On post physics, which is related to the physics engine of Gazebo. Many services here related to the Turtlebot 3 robot. And here we can see our service, my service. Here we have it. Remember that in our program we have named our service here, my service. So here we have our service, okay? We can filter also if we want. The ROS2 service list command using grep, so that we filter all these results and we only get the ones which contain my service, so that we can see specifically the ones which contain my service, which are these ones. In particular, this is the service that we are generating here from our code. Okay? What else? Let's try to get more data from our service. So another thing we can do is to get the type of message that our service uses with this command, ROS2 Service type and the name of the service, which is my service. And this is saying me, hey, your service is using this type of message. From the standard services package, it's using the trigger message, which we can confirm here with our code. So we are first importing the trigger message, and we can see that our service, it's using the trigger message as specified here, right? Then, how does this message look like? We are using this trigger message, but how does this message look like? I want to get more information about this trigger service message. So we can do this with the following command, ROS2 interface show and the name of the service. Okay, so I'm going to run this right now. ROS2 interface show, and I'm going to copy and paste the trigger message here. So this is going to show me the data of this trigger message. Then this is very important. This is a very important part of services. So as you can see, we have 3 lines here. Then all service messages are going to have this structure. They are going to have these 3 lines in the message. And these 3 lines, basically what are doing they are dividing the request part of the message from the response part of the message. So above these 3 lines, we are going to have the request part of the message. And below these 3 lines, we are going to have the response part of the message. Yeah, so let me add, you can see it here in the notebook as well, the output. So let me put, so all service messages are going to have the next structure. So we are going to have the request, we are going to have 3 dashes here in the middle, and below we are going to have the response. Okay, so in this case, above the 3 dashes, we don't have anything. What does this mean? Well, this means that basically our request part of the message is going to be an empty message. Okay, this is what it means. And the response part of my message is going to have this structure. It's going to have 2 variables. One variable of the type bool, which is named success, and another variable of the type string, which is named message. So does these variables remind you of something? Yeah, so these are the variables that we are using in our callback, remember? So in the response part of the message, we are accessing 2 variables, success here and message here. So these 2 are actually the variables that we have in the response part of the trigger message, success and message. You see, so now all this makes more sense, right? Then success is a boolean, so we are setting it to true here, and message is a string, as you can see. And as for the request, we are not using it in this case because the trigger message doesn't have a request. It doesn't, actually it does have a request, but the request part of the message is an empty message. Okay? We're going to see it right now. All right. So we have defined the structure. So the last thing we have to do is to call our service server. Then once we have the service running, we have it running here in the first shell. Once we have it running, we can call it using the following command, ROS2 Service Call. Okay, let me copy it and paste it here in the second shell. So ROS2 Service Call, then we specify the name of the service we want to call, of course, which in this case is my service. We specify the type of message it uses, which is trigger, and finally we send here the request message to the server. So this that we have here is the request. As you can see, in this case it's empty because our service has an empty request. Yeah, so that's why we are leaving this empty like this. Okay, so now if I call my service, let me run it here in the shell. Let me execute this command. We see that the robot starts moving for 4 seconds and it stops. Okay, let me run it one more time. We're going to see the robot starts moving for 4 seconds and then it stops. We can see also here the output, sorry. So the response that I'm getting is success variable is true and the message is successfully called service, which is actually what we are filling here in the code. We are setting the success to true and the message to successfully called service, which is what we are getting here as a response. All right, and of course we are getting the behavior that we were expecting. So our robot is moving forward for 4 seconds and then it stops, which is basically the behavior that we have defined here. So for 4 seconds, for 4 iterations, I am moving the robot forward at a linear velocity of 0.3 meters per second, and after that I am stopping my robot. Okay, makes sense? So basically here we have seen the basic structure of the service that we have created. So let's come back again here to the initial graph that we have here. So we have created the service server code and we have compiled it in this case. Then we have created a client using the command line tools. So by executing this command, this true ROS2 service call, we are actually creating a client here in the shell, which is sending a request message to our server. In this case, the request message is this one, which is empty, as you can see. Then, once we have done the request to the service server, our service server has called its callback function, which is move, which is this one. It has triggered all this behavior, which is to move the robot forward for 4 seconds. And after that, when it has finished it has returned the response to the client. Yes, so here we create the response and we send it back to the client, as we can see here. Yes, so does it make sense? Everything together now? So here we have the whole pipeline of the services that we can see here in our specific example. Okay, so basically this is all, but I have added an extra example here that we can create very quickly. Here it's the where do I have it? The extra example? I don't see it. Here, extra example. So I have created here an extra example. Let me create it very quickly here. I'm going to create a new script, which I'm going to name my service2.cpp. In this case, I'm going to copy and paste this code. And why I have created this extra example? Because in this example, I actually am using the request part of the message. In the first example, we weren't using the request. As you can see from the structure of the message, we don't have a request part. Well, actually the request is an empty message. So in this second example, we actually do have a request part of the message. Why? Well, because in this service we are using this setBool message. And if we analyze this setBool message from the shell, ROS2 interface show std services setBool. If we analyze this message, we are going to see that in this case, we do have a request part of the message. It's this data variable. This is the request part of the message, and down here we have the response, which is the same as the one we were using previously, success and message. But in this example, we do also have a request. So as you can see, in this case, basically the code is the same. The only difference is that we are using this setBool message. So in this case, we have a request. Then we can analyze the request. In this case, the request part of the message is a bool. So when we call our service server, we are going to send this data variable, which is going to be bool. So basically, it's going to contain either true or false. So in this case, in this service, we are analyzing this request, and if it is true, we are going to set the response message to on. If the request data variable is false, then we are going to set the response message variable to off, and we are going to return this. Okay. Then let me create here. Let me add everything so that I can generate this second executable. My service, let me rename it to my service2 server, my service2 server, and my service2 server. And the code is my service2.cpp. Okay? Then let me compile this very well. Let me stop this. I'm going to recompile my package so that my second executable gets generated. So now I'm going to run my second executable, ROS2 run, my service server and my service2 server. There we go. Okay. So now, if I do a ROS2 service list to see all my services, I'm going to see that I have the my service2 here. Now, I can get data again. I can repeat all the process, so I can get some data about my service, but basically I'm going to see my service2. I'm going to see that my service2 uses this setBool message, which is the one that we have just analyzed here. Yeah? Then, now, if I want to call it, I'm going to have to set some data into the request, which is what I am doing right here. Right below the code, you have the command to use in order to call this second service that we have created. So let me copy this and paste it here. So ROS2 service call, remember, we put the name of the service, which in this case is my service2. We put the name of the message, which in this case is setBool. And finally, let me show it here. And finally, in this case, in the request, what are we doing? We are setting the data variable, which is this one here, the variable that we have in the request part of the message. So we are setting this data variable as true. So here inside my program, I'm going to go inside the first option of the if. So if the request data variable is true, which is this case, I'm going to set the response message to on. Then let me execute this and see what happens. And as we can see, so we have sent the request with the data variable to true, and the response sets the message to on. Okay? If we set the data to false, then the response message is set to off. Okay, so I wanted to very quickly show this example so that you can see also an example of services here which also have the request part of the message. Okay, does this make sense? All right, guys, so yeah, we are done. So basically we are done. We have finished it. We have covered everything we had for today's live class. Let me have a very quick look at the chat here. Okay, I can see all the responses. Source, you didn't source the shell, you need to source the setup bash. Very well, very well. Thank you very much for your help solving these problems. All right. So yeah, basically we are done. I have gotten a problem here with my setup. Let me see what happens if I do this. Yeah, so as you can see, my background setup has disappeared. Give me 1 minute. Let's see if I can fix this very quickly. I'm going to switch back to my computer screen. I don't think I'm going to be able to, though. Okay, I'm back again. Let me see how it looks. Okay, we are back to our environment. Great. Okay, so let me have a quick look at the chat here. Thank you for the live course. Thank you very much, Thomas. Can we send something like image back? Yeah, you can send anything you want back. As long as you put it inside the service message. If you put it inside, you can put inside the response part of the message an image message, then you are going to send back a message, or you can put it in the request part. Yeah, so here in our example, let me show it very quickly. In our example, we are using, in our example, we are using booleans and strings, but you can use any other type of message here inside the service message, either in the request or in the response. You can put twist messages, image messages, point cloud messages, whatever you want. So that's completely up to you. In any case, of course, if you want to create, if you want to send back a special message, you are going to probably need to create a custom message. So you are going to need to define a new custom message for services and define here the data you are interested in. Okay, this is another thing, how to create a custom interface. Probably a very interesting topic that we are going to cover in another live class. Thanks a lot for the lesson, says Tom Rowland. Thank you, thanks to you, Tom. Is it possible to send? Yes, you can send anything you want. Or Hirschfeld, yes. So you can send, as I have just said, you can put in the request of the message or in the response, you can put any data you want. All right. In any case, probably you are going to have to create, as I have said, a custom interface. You can create a custom interface and then you can define this message as you want. You can put here as you want, as many data as you want. All right, so let me go back here. So yeah, that's all for today's live class. Thank you very much. I hope you have enjoyed it. I hope you have learned something, most important thing of all. And thank you very much for being one more day here with me. Next live class, let me tell you that for the next week's live class, next Tuesday, we're going to do ROS actions in C++. So hope you are there with me again. And until then, until next live class, as always, take care of yourself, and keep pushing your ROS learning. Bye bye, ROS developers.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS.
From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects.
Want to become a happy Alberto? Request a demo today.